intermediate value theorem. Our objective in this lesson is to use the intermediate value theorem. Intermediate value theorem. Let f be a function that is continuous on a closed interval a to b, and f of a does not equal f of b. If k is any number between f of a and f of b, then there is at least one number c in the open interval a to b for which f of c equals k. Now, what does that mean? Let's take a look at this picture. Let's say this is the x value a, and over here we've got the x value b. Clearly this is a continuous function, and our quick graphical check is we can trace the graph without picking up our pencil. No holes, no jumps. F of a would be this y value down here, that function value, and f of b would be that function value up here. Notice those y values are not equal to each other. K is any number between those two y values. So I'm going to pick a y value right here. That'll be the y value k. It can be any number between those two y values, f of a and f of b. There has to be at least one number c, meaning one x value on our interval, where the y value has to equal that value k. Notice in this picture where that y value k is, the function reaches that k value at 3 different places. Our intermediate value theorem guarantees that there has to be at least one place where an intermediate value is hit. If we think about it a little bit more simply and say f of a is down here, f of b is up here, and our continuous function connects f of a to f of b, any value in between those two y values must be hit at least once. That absolutely has to be true because there's no spot that we can jump over in a continuous function. If we think about it in terms of a real-life scenario, think about your growth. If I were 3 feet tall at some point in my life, and now I am 5.5 feet tall, is it possible to say that at some point in my life I was 4 feet tall? Well, yes, of course. My growth is continuous. I can't go from 3 feet to 5.5 feet and jump over being 4 feet tall. So we would say yes, because the 4 feet that we're trying to prove has to happen is between that lower value 3 feet and the upper value 5.5 feet, and growth is continuous. Therefore, we have to be 4 feet tall at some point. Let's apply it to this function. Use the intermediate value theorem to show that f of x equals x cubed plus 2x minus 1 has a 0 in the interval 0 to 1. Well, of course, this is a polynomial. It's a well-behaved function, so we know it's continuous. We're going to state that first. F of x is continuous on the interval 0 to 1. Now we want to prove that there is a 0 in the interval. That means we're proving that f of x equals 0 somewhere between 0 and 1. Well, let's take a look at what happens at each of these endpoints. At 0, what's the function value? F of 0 equals 0 cubed plus 2 times 0 minus 1. That makes -1. How about at the other endpoint, 1? F of 1 equals 1 cubed plus 2 times 1 minus 1, and that value is 2. Notice that we're going from a negative value to a positive value. So will our function have to equal 0 at some point? Absolutely. So we would say that since the value we want, 0, is between negative 1 and 2, or negative 1 is less than 0, which is less than 2, by intermediate value theorem, f of x must equal 0 for some x value on our interval 0 to 1. And that's how we use the intermediate value theorem. Thanks for watching.